Hello, this is Mr. Best. Welcome to Chapter 8, Homework Questions 29 through 35. Question 29. Find the area in the perimeter of each shape below. Show all of your work. So in Part A, we're given all four side lengths, so all we need to do is add up the four sides. 2 plus 5 plus 10 plus 11 would give us 28 feet. And then for the area, if we break this up into different parts, maybe we could do something like this. Maybe we have to create different triangles here. Maybe two triangles. Just got to try to figure out what way we want to break it up to get it to work. And so, since we have right angles, let's actually break this up so that we can use the right angles to create the hypotenuse. So let's go this way, and then that way we have right angles and we can find the area. So that will then give us an area that's equal to 1/2 base times the height, and that will represent this one. And then we'll do another one that represents, once again, 1/2 base, we can say is 5 with a height of 10. So this area is going to be 11 feet squared. And then, so we'll call that area 1, and then area 2 would be half of 50, and so that'll be 25 feet squared. And then if we add both of those up, we get an area of 36 feet squared. And there might be other ways, and there is other ways to do that, but that's just one way to look at it. On Part B, we have these markings as being congruent. So if that's 20, then this is 20, as this is 20, and this is 20. So it looks like the side that we're missing here is this one right here to find the perimeter, so we will need to find that. We can also split this up into a triangle and a square so that we can find the area as well. We do know this length right here of the square represents 20. It is a right triangle, so we could use Pythagorean theorem. It also is isosceles, which means these are 45, so we technically could use the special right triangle as well. I'll go ahead and just use Pythagorean theorem. That would be 20 squared plus 20 squared is equal to that whole length squared. So that's going to be 400 plus 400 is equal to c squared. 800 is equal to c squared, and then we can take the square root. And so c will be approximately 28.28 centimeters. And so since this is 20, then this extra side that we're going to need for the perimeter would be the 8.28. So to find the perimeter, we can add up all those sides. We have 20 plus 20 plus 20 plus 20 plus 20. So 1, 2, 3, 4, 5. So 5 times 20, and then add in that additional 8.28, and that will give us 108.28 centimeters for the perimeter. Then to find the area, once again we can do it in two parts. We have the area of the square, which is 20 times 20, or 400. And then the area of the triangle is 1/2 base times height. And so the area of the second one would be half of 400, and then that would be 200. So when you add those two up, we get a total area of 600 square centimeters. Question 30. In the figure below, if PQ is equal to SR, so PQ is equal to SR, and let's see, PR is equal to SQ, so that means this whole length is equal to this whole length here. Prove that angle P is congruent to angle S. Write your proof either in a flowchart or a two-column proof. Alright, I'm going to go ahead and use a two-column proof. I have my statement PQ is equal to SR and PR is equal to SQ as my given. I'm also going to identify that this side length QR, which matches up with this triangle right here, is equal to this line segment QR, which matches up with this triangle right here. So once again, we're going to say that the length of QR is equal to the length of QR, and that is by the reflexive property. Alright, and then now, since we have this side length and this side length, and we also still have this one, and now we have the third one, we have that the two triangles are congruent by side congruency. So we will say triangle PQR is congruent to triangle SRQ, and that is by side congruency. And since we know that triangles are congruent, we therefore know that their corresponding parts are congruent, so therefore angle P will be congruent to angle S because of congruent triangles. Means that we're going to have congruent parts. So I used the two-column proof, but once again, you could use the flowchart proof as well. Question 31. Joey used 10 congruent triangles to create a regular decagon. What kind of triangles is he using? If he created 10 congruent triangles, then he's drawn them all to the center of the decagon, which means they would then be isosceles triangles. Alright, and then B, find the three angle measures of one of the triangles. So if it's a decagon, that's 10 sides, so the center is going to be 360 degrees, but since there's 10 triangles, we divide by 10, and that will give us 36 degrees for that angle in the center of one of the triangles. And since it is isosceles, then you can say, okay, well, what's left? 180 minus the 36 is 144 degrees, and that's split between two angles. So that will then give us 72 degrees. So we have 36 degrees, 72 degrees, and 72 degrees for the three angles of that triangle. Part C, if the area of each triangle is 14.5 square inches, then what is the area of the regular decagon? Show all the work. So if the area of each triangle is 14.5, then the area of the decagon, if there's 10 triangles, then we should be able to take 14.5, which is the area of one, times it by 10, and get 145 square inches for the area of the decagon. And that answers all those questions. Question 32, on graph paper, plot the points A and B, and then if C is the midpoint of AB and D is the midpoint of AC and E is the midpoint of CD, find the coordinates of E. So let's start by go ahead and just plotting the point 2, 2, and then 14, 10. We'll have to, I guess, approximate this. 14, this will be 11, 12, 13, 14, and then 10 will be somewhere up here. And I could have went by 2s, but we'll just approximate it out there. So if C is the midpoint of AB, so we can find the distance of C between these 2 points. A couple ways we can do that. We can find the difference and then divide by 2. We can add them up and divide by 2 to figure out what the coordinate is. So I'm just going to take C and I'm going to take 2 plus 14, divide that by 2. I'm also going to take 2 plus 10 for the y coordinate and divide it by 2. So that would be 16 divided by 2 is 8, and then 12 divided by 2 is 6. So at the point 8, 6, that would be point C. It says D is the midpoint of AC, so now we want to split that one up. So D and A and C. So A was 2, 2. So now to find D, we're going to take 8 plus 2, divide it by 2, 6 plus 2, divided by 2, and so 10 divided by 2 is 5, 8 divided by 2 is 4. So D is at 5, 4, so we're right here. And then E is the midpoint of CD, so in between C and D. So C was 8, 6. We're going to find the midpoint between those two, and that will be point E. So point E, we have 5 plus 8 divided by 2, 4 plus 6 divided by 2. So it looks like E will be located at 13 divided by 2, 6.5, and then 10 divided by 2 is 5. So point E will be located at 6.5, comma 5. B, what fraction of the distance from A to B is E? So I'm going to plot E just so we know where it's at. 6.5, what is it, 6.5 and 5? So about right there. And so when we started, AB was the length, then AC, that's half of AB, and then AD was half of that, or a quarter, and then DE was half of a quarter, which is an eighth. So if we look at it, this would represent, 1/8, 2/8, 3/8. So for part B, what fraction of the distance from A to B is E? That would represent, once again, that would be 1/8, 2/8, and 3/8. And then for part C, use the ratio from part B to find the coordinates of point E. So for this, we would probably want to go back to the lesson. I believe it's looks like 7.3.2 in terms of how we were finding the points in between. So if we go back and look at that on part C, if you look at A and B, 14 minus 2 is equal to 12. So that's the total distance between those. If I want to find what 3/8 of 12 is, I can take 12 times 3/8, and that will give me 4.5. So that would be that distance, but I'm starting at 2, so therefore I'd want to take 2 plus 4.5 to get 6.5. And that would be my x-coordinate of E, 6.5. You could also subtract 4.5 from your value of, well, I take that back, because it's 3/8, you would have to subtract 5/8 of it. So yeah, you'd want to add it on to the 2. You can do the same thing for the y-coordinate. We're going to go ahead and do the y's is, the distance is 10 minus 2, so that's 8. We want to take 3/8 of 8, which would be 3. And so if you add that on to your y-coordinate, the y-coordinate is 2, similar to the x, but then we add 3, and that will give us 5. So that's another way that you could find the point E if you know it's 3/8 of that distance. Question 33, use the geometric relationships in the diagram below to solve for x. We have 82 degrees. We also know it's an isosceles triangle. So we know that 180 is equal to x plus 82. So we can subtract 82 to get 98. X plus x is 2x. Divide by 2. And x is equal to 49 degrees. On part B, once again, we have an isosceles triangle. So if this is 71, that means this is 71. So 180 degrees minus 71 degrees minus 71 degrees will give us the value of x. And so therefore x is equal to 38 degrees. Question 34. The arc below is called a quarter circle because it is 1/4 of a circle. Part A. Copy region A below onto your paper. If this region is formed using 4 quarter circles, can you find another shape that must have the same area as region A? Justify your conclusion. Alright, so here's my thought on this, is that we have 14 units in terms of the diameter. Alright, so both of these would be 14. And then if I draw a circle in here, alright, it creates these corner pieces. And then if I cut my circle in half, then I have kind of this part up here. So we want to know what the area of this is. And then these two regions down here, because the quarter circles are turned to kind of go outside there, these would be the two that I have left. Well, if you take a look at that, does it make sense that these two corner pieces on the bottom would be the same two corner pieces on top? And hopefully visually that does appear to be true. And so if that is true, then the other shape that we could form is a rectangle that's 7 by 14. Now, if we want to go a little deeper with this, we can and say, well, it looks like it, but is that really what's happening? Well, like I said, if we want to go a little bit deeper in this, we could say, all right, well, we want to know what the area of the circle is. So let's find the area of the circle. Well, the area of the circle is pi r squared, so r is 7, so square that. That would be 49 pi. Now, we only want half of the circle, though, so instead of the whole area, what is half the area of the circle? And that would just be half of 49, so that's 24.5 pi. Now, what are the four regions? Well, we could take the entire square, which would be 14 times 14, so that would be an area of 196. So this is going to be the four corners is what we're going to find. So once again, the whole thing is 196, and then we want to subtract the area of the circle, which we have above is 49 pi. So that would represent the four corners, but we only want two of those. So if we only want two of them, then we can divide that by 2. That would get us 98 minus 24.5 pi. So what are the two things that we want to add together? We want half the area of the circle, and we want two corner pieces. So if we add that up, that's 24.5 pi plus 98 minus 24.5 pi. You can see the 24.5 pi is going to cancel, and that will then give us the area of the region A to be 98 units squared. So there's kind of a more mathematical approach to that, but once again, the visual will probably kind of give you enough to go with that one. B, find the area of the region. That's what we just did down here. It is 98 units squared. 14 times 7 is also 98. Question 35, multiple choice. Which property below can be used to prove that the triangles at the right are similar? Well, we have an angle measure here and here. And we also have some side lengths, as long as their ratios are the same. So this length here, 4, could match up with the 6. So 4, 6 would then have to be equal to the same ratio here, which would be 6 over this length of 9. So 4, 6 reduces to 2/3, 6 ninths reduces to 2/3. And since those are the same, we can do side, angle, side similarity.